So my last episode, I talked about the data plane IP packet flow, and also mentioned those FTP entries are created automatically by the flannel daemon agent on each node, including those VTAP for the flannel interface. And let's talk more about that. So right now I have two node here, master node, workload. There's no any pod running. I have not applied the kube flannel YAML file, and by the way, I draw a new diagram to explain the control plane workflow here. So I'm going to apply this command to the API server, and let's see what happens. Before I apply that command, let's run this guy. I want to see what the node, what information the current workload has. Let's get a output first before we apply the YAML file, and after we apply the YAML file, let's describe the node workload again and see what information and get added to the workload. Okay, so now let's apply the YAML, kube flannel YAML file. Okay, maybe spell wrong, maybe I don't have this A. Yeah, so we applied the kube flannel YAML file, and so this YAML file includes the config map and a daemon set. So now kube flannel pod should be running on the workload, also on the master node. I didn't draw it out. So here, let's check the pod. It should be running. Yes, so two kube flannel pod running on each load. So let's get the describe the node workload again. Okay, so now let's diff that file. Before, after, okay, let's put it to a file. Let's see what's change made to the workload after applying the kube flannel daemon. So, did you see anything new here? So this is before the annotation about the node, the workload. This is after, this is the annotation after we apply the kube flannel daemon set. So some new stuff added. As you can hear here, what added? The VTAP mag get added to the node. VXLAN, backend VXLAN, then public IP, which is a workload IP. So yeah, so some new information added to the workload. Yeah, so that it that this both command, those config map and the daemon set, kubectl take that input and apply it to the API server. And the kubernetes, according to this daemon set config, it will start up the kube flannel pod. So what kube flannel does is, this pod does is, it has two main tasks. I can show you that what it does with two main tasks here from the code comment. This is a GitHub flannel source repository, and the first thing it does is to get a subnet release for each node, and the subnet will going to be used for the pod sider, for the pod network on that node. So what it does is it will get a release subnet and write it to this file, on the node. This file contains the big/16 subnet in the config map we put, and this is the /24 subnet for the pod on that node. And so that's the first thing. The first thing flannel daemon agent gotta do. The second thing, I think we already talked about it. The flannel daemon agent will create flannel.1 VTAP interface, and the actual code here is the vxlan.go backend. So this vxlan.go basically has three things to do, which is create a routing table entry for the remote subnet. So let's see if that is the case. IP route show remote route entry for the remote subnet. Yes, so this is the remote subnet on the worker load, and through this gateway, through this VTAP interface. So yes, that's the first thing you gotta do. Second, create a static ARP entry for the remote flannel host IP address. Okay, and the VTAP MAC. Okay, let's see. ARP flannel.1. Yes, so it has static ARP entry for the remote subnet, and let's see what this guy is. Okay, so this is supposed to be the VTAP MAC. Let's see. Let's see if it's the VTAP MAC here. Okay, let's kubectl describe note. Yes, so that's the VTAP MAC for the worker load, and yes, so this is the VTAP MAC for the remote workload, which the remote VTAP MAC, the remote subnet through the flannel interface, and this VTAP MAC should be the MAC address of the flannel.y interface on the workload. We can double check that. Yes, so that's the VTAP MAC. Okay, so this is the second thing, and the flannel daemon gotta do. The third thing is create an FTP entry with the VTAP MAC on the public IP of the remote flannel daemon. So it will create an FTP entry. So can we see a FTP entry? Great. FTP show dev flannel.1. Yes. So our FTP entry, this is the remote VTAP MAC, remote VTAP host, and so that's this VXLAN code does. So yeah, there are more source code. We can go to the source code later, but we don't need to show it here. So this is the control plane workflow diagram. Again, kubectl apply this config map, daemon set. So this is to Kubernetes knows the CNI plugin to use, flannel. And so as you can see, the Kubernetes will get information from the API server. And yeah, so this daemon set, this one is actually very important. Before start up the flannel pod, it copy a file from here to here, which is the on disk file on the node. So the kubernetes, the actual content is something like this. It's basically tell kubernetes what CNI plugin to use and what delegate plugin to use, which by default is a bridge plugin. So the kubernetes will read this file when kubernetes started, and it will prop the CNI plugin and set up the default network for pod, and it knows Kubernetes knows to use flannel plugin to start a pod, and yeah. So this container definition here is to how to run the flannel daemon agent on each node. We explained it before, and so once this kubeflannel pod is running, it will also contact the API server to for the subnet release, the first task to get a subnet release out of this subnet, and write it to this file /run/flannel subnet, and it contains this subnet release. This is an on disk file on each node, and the kubeflannel plugin, which we haven't talked about, the kubeflannel plugin will create we can talk about kube plugin, CNI container network container network interface flannel plugin later with more detail, and but here is just what this part does. Write this subnet release file and create this flannel with tab interface, create a flannel interface, and do these three things. So that's why it works. Everything works. We applied the kube flannel daemon set, and yes,